Hello, everybody. Thank you, Dr. Borant. My name is Farsad Afshinnia. I'm an instructor at the Division of Nephrology. Yeah. Is it better now? Yeah. Okay. So by now, there have been several presentations talking about targeted analytic platform. So I take this opportunity and review a study which has been published a couple of years ago, which discuss about relevant clinical questions in field of nephrology. So the objective of this presentation is to demonstrate an example of how this targeted metabolomic platform can be used to answer a relevant question, and also to demonstrate some of the technical aspects of analysis, including a compound by compound analysis and multivariable analysis in the conduct of the project as we move forward. More will be covered in the next sessions and also tomorrow, but for now, basically, as I know that the diversity of the audience is enormous, so for those who are not clinicians, chronic kidney disease is a major public health problem in the United States and all over the world. Currently, there are over 20 million people with CKD in the country. And also, we know that it has a lot of morbidity and mortality, and therefore has a major public health burden. The practice of clinical nephrology up until now has been mainly limited to application of very few biomarkers, including glomerular filtration rate, or GFR, to demonstrate how a patient is doing in terms of the kidney function. But as you may know, GFR is a index that is, in order to measure that, it's first of all very technical. It's very challenging. Not every medical center is able to directly measure GFR, and it takes a lot of time from patient and staff. And bottom line, it's not feasible. So in order to make it as simple as measurement of a serum creatinine, then we have to come up with estimating formula, such as estimated GFR formula that uses several different characteristics, including serum creatinine, age, race, and gender. But by virtue of using the estimating formula, you can imagine that we lose precision and we lose accuracy. Particularly when the patient's serum creatinine is closer to normal range, you can expect to see that the eGFR estimating formula are not really doing well. The other biomarker that we use a lot in clinical practice is urine protein. More recently, KDIGO guidelines, clinical disease improving global outcome, has come up with this graph, heat map, which categorizes the GFR from up to bottom, and proteinuria from low to high, and has come up with a map showing that basically if you fall into the green area, you are risk stratified as a relatively healthy subgroup of people. But essentially, if you are in the red area, you are at high risk of progression to end-stage kidney disease if you are not already there. So what is the problem with that? The problem is that if you are in the red area, you're almost done. So it's too late for literally any meaningful delivery of good clinical intervention to get a good outcome. So the question is basically, what can we do in a scenario that patients still in the green area, and identify those who are at risk in order to do something to prevent bad outcome? So the currently available biomarkers, first of all, reflect the advanced stages of chronic kidney disease, and the prognostic and disease-specific markers at early stages of CKD are basically lacking. The aim of this study was to identify the predicting metabolites of plasma at early stage, and by early I mean when the patients are literally on the green area, to predict the incidence of chronic kidney disease. So the Framingham Heart study was used as a platform for this study. For those who are not familiar with Framingham Heart study, it is a cohort of individuals that for the first time was established in 1940s. The first generation of that cohort actually established the second generation in 1971, and that included more than 5,000 individuals. From that group of individuals, in the fifth examination from 1991 to 1995, close to 3,800 individuals were examined. And out of that number, over 2,000 had the metabolomic profiling. From that, 689 patients were excluded due to some technical problems and missing. And at the end, the study ended up with 1,434 individuals that had serum plasma samples available from baseline, and baseline is defined as the examination in the fifth period of physical exam. So the chronic kidney disease was defined when estimated GFR dropped down to below 60 ml per minute, and that was an outcome that on average was assigned to each patient 8 years earlier. So fast forward from 1991 to 1995, we had 123 patients with CKD, and the rest of the patients were essentially remained stable. So using a targeted metabolomic platform, three distinct LCMS-based methods were used in order to identify a group of amino acids and amino acid derivatives, 104 lipids, including several different lipid classes, and 59 different organic acid, sugars, bile acids, and some other negatively charged polar metabolites. So how these were chosen? Most of them were based on a priori knowledge that the investigators thought that they had based on the available literature until they set up a panel including these 217 different metabolites. So this slide shows the baseline characteristics of the two groups, progressors and non-progressors. And as you can see, those who progressed to CKD at baseline were a little bit older, 61 years as compared to 54, were more likely, a number of women were a little bit higher, BMI was about the same. They were more likely to have hypertension and diabetes, and the GFR to begin with was slightly lower in progressors as compared to non-progressors. But over time, when the study ended up, basically the progressors had much lower GFR as compared to non-progressors. Okay. So this is the volcano plot showing the differential by status of progression versus non-progression. Basically, each one of these dots is indicative of each one of those 217 metabolites. And you can imagine if the mean of metabolite in the two group is essentially identical, the ratio is 1. So when you see that the dots are at 1 or close to that, it means that basically the two groups were identical in terms of that specific biomarker. And as the dot starts distancing from 1, it indicates that the difference is getting more pronounced. It will be more significant and probably more of clinical importance if at the same time when the dot starts to deviate also gets a very significant p-value. As you can see, the p-values are in the y-axis. So literally speaking, those biomarkers that fall in this area or in this area would be of major clinical interest. So by now, we showed that there are potentially some biomarkers that have passed the statistical significance, but how do we know how many of them to consider as have passed the statistical significance? So one of the ways that the authors used in this study was a correction for Bonferroni for multiple comparisons. And the cut point that they used was basically 0.05 divided by the number of metabolites, and that led to the top 16 metabolites that have passed that threshold. And as you can see, these p-values are highly statistically significant, which are all lower than that p-value. I didn't do anything. Okay. So another aspect of looking at the same data, these are the top 16 metabolites that So these are the top 16 metabolites that have passed the statistical significance. And the idea is to show that as compared to creatinine, which is highly correlated with glomerular filtration rate, they are basically not correlated with baseline GFR, and trying to suggest that whatever underlying pathology has been involved in differentiating is likely independent of the baseline kidney function. So the authors also used a unique and novel approach to understand the physiology of changes of some of these metabolites. What they did, they went ahead and used the information of 9 patients that were chosen to undergo cardiac catheterization. So at the time that the patient went for heart catheterization, they sampled from both renal artery and renal vein. I think most of the people have the slides in front of them, so I keep going, and I apologize for the interruption. But basically, the authors had, through the angiogram, biosampled the blood from both artery and vein. And here, basically, they have been able to show that from arterial side to venous side, the serum creatinine has come down significantly as a reflection of the underlying functioning kidney. And also in panel B, you can see that what they measured with mass spec was highly correlating with the measurement of the cohort that has already been done in the file. In panel C, you can see that a bunch of metabolites has decreased in concentration from arterial side to venous side, suggesting that a patient is either filtrating in the urine or the patient has active tubular secretion. But at the same time, you see that a subgroup of metabolites are also increasing in level, suggesting that probably there is a role for active anabolic or metabolic kind of role for tubules to the point that the venous concentration of the material or metabolite is higher. And this is basically the average by patient level, and also for all the group nine patients by category of the metabolites that have decreased or increased. And as you can see, some of the metabolites have had lower concentration, and those that have reached to a higher concentration are listed here. So by now, the potential biomarkers have been identified to be some urea cycle intermediates such as citrulline, choline, tryptophan metabolites such as kynouric acid or kynorenin, 5-hydroxyindole acetic acid, and some intermediates of citric acid, purine metabolism, and pyrimidine metabolism, including xanthosine and beta-amino butyric acid. So this is also another way of showing the same information. As you can see, the fractional excretion of citrulline and choline has been very low as compared to fractional excretion of kynorenin, which is very much higher as compared to serum creatinine, suggesting that basically the tubules might have an active role in actively secreting the kynorenic and tryptophan metabolites into the urine above and beyond what you can expect from GFR. So one of the questions that you may ask is that at the beginning we showed that a lot of the characteristics of the patients at the beginning of the study were different between progressors and non-progressors. For example, there were more likely to be a woman, rate of diabetes and hypertension was higher. What if some of these highly statistically significant metabolites that have reached to statistical significance are just defined by baseline characteristics? And that's why a modeling, multivariable modeling with logistic regression, adjusting for all those covariates have been applied in an attempt to see if the statistical significance remains after adjusting for all these background variables, and whether or not that could change the results as confounders. And turns out that basically, even after adjusting for all these variables that have been significantly different at baseline, a lot of the statistically significant metabolites have remained to be statistically significant. And that's, for example, kynorenic acid is associated with 53% higher risk of progression as compared to non-progressors, even after adjusting for all those background variables. Another aspect of the question in biomarker discovery is whether or not the newly identified biomarkers are doing anything better than the information that we could have from baseline variables. And baseline, by baseline, I mean EGFR and whatever information that we could obtain. And for that matter, we can look at the area under curve of receiver operating characteristics curve and see what the C-value is. And if you look at the C-value from base model, it has been 0.77. And by application of the top 5 metabolites, the C-value has increased from 0.77 to 0.83, and that has been highly statistically significant. And that suggests that the addition of the biomarkers is likely to be of value in improving the prediction of progression to CKD. Then in another model, they also used the top 3 instead of top 5, and still they got a highly significant improvement in C statistics, suggesting that even with 3 top differentiated metabolites, the prediction of progression has been better than when you just used a basic model. So in conclusion, this study suggests that there are subset of metabolites that may predict incident CKD, and they might have had added value to the currently available biomarkers. This study also has some limitations. Basically, as you saw, basically authors used a very limited number of metabolites in a targeted manner, and therefore there are many more that potentially could be used, and maybe an untargeted platform can still add some more information. Possibility of false discovery is an issue in this study. As you can see from the method, the authors used EGFR as a method to ascertain the outcome. That itself is application of an estimating formula and not a gold standard of measuring the renal function. The study population has been predominantly European ancestry, and therefore it lacks any diversity in race, and therefore may not be applicable to other patients' population. And as I mentioned earlier, a limited number of metabolites have been investigated, which leaves the room for further studies. With that, I stop here, and I welcome you to ask your questions if there is any. Yes.
So can you go back to a couple of slides? So you showed the 5 metabolite and 3 metabolite comparison table.
Yeah.
Yeah. So what is the base? So base model include which factor?
So base model includes mainly EGFR and urine protein proteinuria.
Okay. So then, so at the beginning you mentioned that you showed the kind of heat map, and then how the person in the green area.
Right.
And so when you know this, I don't know how to pronounce it, but kynurenic acid, and so then if we know that those factors can predict the future incidence of this kidney disease, so then how the physician can intervene to prevent? So then is there any like the medicine or any?
So that's a good question. Basically, this is just the discovery phase of this study and the relevant future questions becomes which pathway they belong to and whether or not they are amenable to intervention, and whether or not if we intervene, we could change the outcome. Those are follow-up questions and follow-up studies, which this study is unable, obviously, to answer. But that's the first step to identify that, yes, there is a problem. There is something above and beyond the traditional biomarkers that potentially can shed some light. But could that change, or could that be a target of any intervention? That requires further studies. Yeah. Okay, thank you.